Hello everyone, welcome to the Open AGI Forum. I'm Wei Lu from CSDN, covering live streaming from Delft, Netherlands. We are honored to have Ed Page to join us today. Welcome, Ed.
Thank you.
Could you briefly introduce yourself to our audience first?
So my name is Ed Page. I've been doing software development for a couple of decades. I started off as a C++ developer, focused a lot more on operating systems, driver development, that kind of stuff. And over my career, I slowly started focusing more on developer experience, build tooling, things like that. And eventually have now gotten to the point of I'm now full-time working within the Rust community to work to improve the experience for Rust, both working on the cargo team I'm wearing the shirt, and then also just working on different packages throughout the ecosystem.
That's great. After working as a C++ Windows driver developer for many years, what prompted you to switch to Rust, and how has your prior experience influenced your current work?
So I've been writing C++ since before C++ 98, and I've seen a lot of languages come and go through that time. I've seen like people saying, "Oh, Java's going to kill C++ and replace it." D is going to come and replace C++. Go is going to replace C++. And as each one happened, like it pulled away a part of the C++ audience, but it never really got to the core part of C++ that I was caring about. So I knew that there were problems with C++, but it was there's a quote something like, C++ is bad, but so is everything else. I can't remember the exact quote. Sorry, I'm butchering it, but just the fact that I recognized there's flaws, but there was nothing better at the time. And so when I saw Rust, my first thought was, this is finally, it solves some of those key problems that those other languages weren't solving, that helps fit within that operating system embedded space that has been underserved so far. And so I'm like, I want to do whatever I can at this point to be able to help make sure that this is successful, so it can actually help to be able to one day supplant C++ as the primary language used for these kinds of things.
Okay. So as a maintainer of the key Rust tools like Clap and Cargo release, what have been some of the most significant challenges you have ever encountered when maintaining these tools?
One significant challenge is time. So at first, my involvement in Rust was just in my spare time, but then as I started to have a family and things, my spare time went away, so I didn't have much time for it until I was able to get this role with Future Way to be able to work on Rust full-time. And so I just didn't have the time for these things, and even having the time for it, there's just too many things that too many problems I want to solve, and not enough time for me to be able to solve them in a day. I have a queue of things I'm wanting to solve that's probably over a year out. And so it's going to be taking a while to be able to work through all these things. So time is a big one. Another big one is just trying to navigate everyone's needs and trying to figure out who to prioritize and who I have to say no to. And that can be a big challenge, is figuring out the issue of saying no.
Okay, so what features or improvement that you implement are you especially proud of?
I mean, one was one of my first big contributions to Cargo, which I didn't write the initial feature for this, but I helped to get it over the edge and into Cargo, which is the Cargo add command, where you can just run a command to be able to add a dependency to your package. It was something that I personally hadn't been using until I actually started working on it, because just it being a third-party tool, I was like, I don't want to install a tool just to be able to add a dependency. But now that I've added and I've tweaked it and worked to improve it, the experience for it is really nice. So that's just, I mean, there's probably other things, but that's one that's easy to point to. Yeah.
So as a member of the Cargo team, what are your primary responsibilities, and have you collaborated with other team members to drive the development of Cargo?
So the Cargo team, this is something that can be an easy mistake to make, is it can be easy to think that the Cargo team is, oh, we need to say, Cargo, we need you to go do something. The Cargo team goes and does it. And that the Cargo team leader is the decision maker for the Cargo team. It isn't like that at all. The Cargo team is the deciders for what features go into Cargo, or they help people to get their designs over the line so they can be approved by the Cargo team. They're basically just the decision makers, while yes, we sometimes work on the implementation and make sure to help get things done. We can't be there and do everything for everyone. So our primary focus is on the decision making and on the long-term maintenance side of things. I can't quite remember what the second half of that question is. What was that again, about collaboration with the other team members?
Yeah.
So like part of the collaboration is on just discussing the designs people put forward to be able to get things going. Let's see, I'm trying to think of any more specific examples to be able to give on some collaboration. Like one feature that's being worked on right now is we've not had a way to be able to report very good diagnostics to users. Like we have great errors and lints from Rust and Clippy. We've not been able to do that for the Rust cargo users. And as cargo's been growing and we've been finding patterns for how people should be using it, we've been finding the need for that. And so I've been working a lot with another member of the cargo team, Scott, and he's been doing a lot of the work on that. I've been helping out here or there with it, but that's an example of us working together to try and make sure that feature gets through so it unblocks a whole bunch of other features that people can work on.
So what's the upcoming features or changes can user expect from Cargo?
So a really big one that's going to be important for companies is it's referred to as the MSRV aware resolver. It's where MSRV is minimum supported Rust version. That's where a package can be able to say, declare, I work with a version of Rust as old as X. And the MSRV aware resolver, what that'll do is when you make any changes to your dependencies or you go to update your dependencies, it'll make sure that it'll pick dependencies that are compatible with your declared minimum Rust version so that way you can just make it work. And like with Rust, we try to make sure that the quality is there and the compatibility is there, that it should be safe to upgrade every 6 weeks. But we recognize that that doesn't work with all business processes. There's businesses that might have different validation steps they might need to do, or they might need to focus on one thing and then be able to take some maintenance time to go and work on things like doing upgrades. So you might not have it as readily in their process to be able to be doing upgrades every 6 weeks. So doing things to make it easier for them to to find their dependencies while they're on older versions of Rust is going to be a very big improvement for them. Another big one that at least I've been working on is called Cargo Script. It allows you to have a Rust file that you can be able to also put your dependencies inside of it directly rather than having a separate cargo.toml file. This makes it very easy just to throw together an experiment, or to, when you go and create an issue, to go and put the issue up on GitHub and have it mention everything needed for people to reproduce that issue. If you want to communicate with a coworker over a messaging platform, you can send them the entire thing. So it's going to make it a lot easier for people to just prototype, experiment, and share what they're doing. So I'm really excited about that feature.
Yeah, it's exciting. You have shifted your focus to improve the developer experience, particularly regarding build tools and process. So could you share some insights on the key improvement you believe is necessary for Rust's tooling system to better serve the community?
So there's probably a couple of areas that we need to be focusing on in Rust. I mean, one I just mentioned is the MSRV aware resolver, where it's going to make it so there's going to be a lot less work to for people to go through. Actually, I was talking to somebody recently where they were like, my CTO is breathing down my neck about how much of a drain it is on all the employees to have to deal with these old dependencies.
Yeah.
Another important thing is going to be on build times. We have a rough sketch of a design. We need somebody to have the time, again, that time problem. We need somebody to have the time to work on finishing it to try to better improve the caching within Cargo so we can be able to improve the build times for people. And then probably one of the next big things is more work on supply chain management. There's work on SBOMs that's ongoing, but there's other things like being able to better track vulnerability reports for your code, better being able to track who it is that made changes to your dependencies and how do you better view your dependencies. So those are some of the areas I think are going to be really important for the developer experience and developers being able to trust what they're doing.
So in your role at FutureWay Technology, what specific aspect of Rust are you working on to improve in FutureWay?
So my role at FutureWay is kind of a unique one. I am full-time actually working towards the Rust community. So everything I've talked about is all part of my work at FutureWay.
Oh, okay. It's a special thing. Yeah, so we know this. Before Rust, you worked with C++ and Python. How do you compare this language with Rust?
So C++, I kind of mentioned that as part of my evolution where I'm like, I see that has flaws, and there's still strengths to it. That does not necessarily say that like there's a one be all end all language. I mean, One example of that is specialization. We don't have that in Rust yet, and that's something that you can do a lot of powerful things in C++. Another example is, I guess you could refer to it as generic duck typing, where in Rust, and in you can now start doing it in C++ with a feature called concepts. You have to specify what interface all of your generic parameters works with. But there's times where it's like, I just want to be able to, deep down in a stack, be able to just do something real quick during my debugging. And it's really nice just to be able to be like, print this as debug, but I didn't necessarily through the whole stack say that this has to be debug. And so sometimes it's nice to be able to have that little bit of flexibility there. So that's contrasting with I feel like there's a lot of weaknesses in C++, which I think I don't necessarily need to enumerate at this point. I think there are strengths that we need to call out and recognize and try to see how we could be able to gain benefits of those improvements within Rust. For Python, I really enjoyed Python, and I felt that there was times where I could just look at my code and be like, this reads like pseudocode, like this is so clean. Yeah. But one of the areas where I became disillusioned with Python was the tooling area. It is scattered, it is a mess. I mean, there's an XKCD about it. Yeah. So that's one where, and I've found that there's times where I can write Rust code that starts to actually feel like Python. That's actually something that I mentioned, cargo script. That's one step in this effort, but I actually, again, I've actually kind of sketched out the idea of like, what if we had a standard library alternative that tried to hide away a lot of the low-level details Rust tries to help you optimize for, and just tried to make it feel like more like writing in Python. So you get all those benefits of Python of being able to quickly throw together code, prototype it, get it compiling and building and stuff, but without as many of the downsides of, well, yeah, sometimes it's nice not to have to do all the typing, or sometimes it's nice to be able to take advantage of the types not being there, but there's all the errors that you get from the lack of static typing in Python. Yeah. And there's different other trade-offs to Python, but I feel like there are some downsides, there's some plus sides, but I'd like to see us work to pull some of those benefits of Python into Rust so we can all benefit from it. Yeah.
Have you ever tried to use Copilot or ChatGPT to generate Rust code?
I have actually not used any of the AI tools. Okay. I've not used any coding assistants like that. I actually barely even use LSPs, like Rust Analyzer. Yeah. I actually want to rip it out of my text editor. I accidentally enabled it for once, and I'm like, no. Okay, yeah. Well, I'm asking this question to compare Python or Rust is because, in the large language model, Python is almost the native language of these models. Oh, really? So yeah, the performance on C++ and other languages is relatively lower than this. So I think we are doing some, in CSDN, we are doing some work to try to improve the performance of LLM on C++. Okay, because I actually assumed that Python would be harder to do LLM on just because, granted, I don't know all the details of them. I don't have an AI background or machine learning background. I assumed that because there's more strict information about what's happening, you could be able to better harvest that information to create better code suggestions.
Yes. There's differences on the LLM's ability to generate or process different languages. I think we think there may be a lot of work to just make it more fair for different languages in the AI area. Yes. And so the last question is that what advice would you give to developers who are interested in creating or maintaining development tools in Rust? What are the best practice or considerations to join the ecosystem for the new developers?
One thing I'd probably say is don't sweat the details. Oh, okay. It's too easy. Like, I'll actually step back. When you have people like Burnt Sushi who go and create ripgrep, and there's so much performance behind it, you see all these other showcases of all these like super high performance things, and because of the low level control that Rust gives you, you can spend too much of your time trying to optimize every little thing and not keeping track of things like Amdahl's law of like, does this actually matter? Yeah. You end up wasting all of your time and you don't actually get anything done. That it's like somebody I know has a shirt that says keep calm and clone. And that's just the idea of like, Don't worry about making everything in Barrow and all these complex lifetime things, especially when you're just trying to get a CLI out or something like that. You're just learning, like, just get the code working, accomplish what you're wanting to do, then you go and use the performance book to figure out how to make it faster, and then worry about it. And most of the time, you probably won't even matter what clones you did.
Okay. Yes, great. Great, thank you, Ed. Thank you for the insightful discussions.
Thank you.
And thanks for all the developers watching. That's all for today's interview. See you next time.
Bye.